Hello, you are welcome to this video. If you are seeing this channel for the first time, please kindly subscribe to my channel and hit the notification bell to receive notification anytime I upload new video, and don't forget to share it with your friends. That is how you could support my mission. In this video I'll discuss set notations, okay, and we are going to consider the following set notations: cardinality of a set, union of set, intersection of set, subset, proper subset, superset, proper superset, and power set. So let's look into them one after the other. The first one is cardinality of a set. So this is the number of elements in a given set, the number of elements or the number of members in a given set. Take for instance, you have set A to be equals to 2, 4, 6, and 8. So in this case we have 4 elements there, so that is the cardinality. So the cardinality is denoted by this sign n into the set, okay. So that means you have 4 elements there. So this means the cardinality of set A, the members of set A, the number of members or the number of elements in set A. If you have another one here, let's say set B is equals to A, B, C, D, E, F. So we have 6 elements. That means the cardinality of set B is equals to 6. Okay, that is the number of elements in set B. So that is the meaning of cardinality of a set. So when you see this sign here, it means the cardinality of set B, the number of elements in set B. Let's look into another one. That will be union of sets. Okay, so union of sets is nothing but the combination of the elements, okay, in the given sets, okay, either the one common to the 2 of the given set or the one in each of the given sets. Let's look into this example. Given that set A is equals to 1, 2, 3, 5, and set B is equals to 2, 4, and 6. So to get A union B, so this sign here, okay, the sign here, this particular one means union. So this is read as A union B. So is the combination of elements in either set A or set B, or elements in both sets A and B. So if you want to get A union B now, so it will be the combination of all these elements. Now you can see that we have 2 here, we have 2 here, so that is the common element, okay. So the elements in A will be 1, 3, and 5. The elements in B will be 4 and 6. Then the element that is common to the 2 sets is what? 2. Okay, so that is the meaning of A union B. That is the combination of the element in set A plus the combination of elements in set B plus the element in the 2 sets A and B. So in a nutshell, what A union B simply means is that you should combine the elements in the given set, so which you could easily write as 1, 2. So I've written 1, I've written 2, then 3, then followed by 4. Okay, so you can see that I have 2 here, I have 2 here, so I don't need to write 2 twice, because in set repetition is not allowed. Okay, repetition is not allowed. So even though you have repetition there, you count them as 1. Okay, so I've written 4, then the next one will be 5, okay, and 6. Okay, so that is the simplest way you could get the union of sets A and B, just to combine the elements in the 2 given sets. So that is what it means. Okay, so intersection, the next one will be intersection. So given that set A equals to this and set B equals to this, so what is A intersection B? Look at this sign here. It means that's a set notation for intersection. Intersection means the common element. So this is read as A intersection B. It means the common elements in A and B. Now to get A intersection B, it will be the common element. So 2 is here, 2 is here. So I'll write 2 here, and there is no any other common element again. That means the intersection of sets A and B is 2. So the next one will be disjoint sets. So 2 or more sets are said to be disjoint if they don't have common elements. Take for instance, you have set A to be equals to 1, 3 and 5. Then you have set B to be equals to 2 and 4. In this case, A intersection B will be equals to an empty set. Okay, so that is a disjoint set. Okay, so that means there is no common element. So we are going to have, or you could write it as A intersection B is equals to empty set like this by using a pair of curly brackets. So it's either you write it like this or like this. So anytime you have 2 or more given sets and there is no common element in the given set, so that means you have a disjoint set. Okay, so the next one will be complement of a set. Okay, so the complement of a set could be written as A to the power of C like this, that is A complement, or A prime like this. Okay, this is commoner, or this is more common, that is A prime. Okay, so literally it means not in A. Literally it means not in A. So not in set A. So if it is not in set A, then where will it be? Then it will be in the universal set. So that means we can say A complement is the set that contains elements that are not in set A but in the universal set. So look at this example here. We are giving set A to be this, and we are giving the universal set to be this. So A complement now will be all the elements that are not in A but are in the universal set. So let me cancel. 1 is here, cancel it. 2 is here, cancel it. 3 is here, cancel it. 5 is here, cancel it. So all the elements that are not in A but are in the universal set are 4 and 6, as you can see there. That means A complement is the set of 4 and 6. Okay, so that means the elements that are not in A but in the universal set, that is the simple meaning of A complement. Okay, let's go to another one, that is difference of 2 or more sets. Okay, so it's just like you are taking away like your minus sign here. So if you are giving 2 or more sets and you have to find A difference B, or B difference A, or A difference B difference C, so it's very simple. It's just like the complement, but the difference of 2 sets occurs between 2 sets. Okay, why the complement is between a set and the universal set. That's just the difference there. So A difference B means all the elements that are in set A but not in set B. Okay, so in this case now, A difference B will be, so all the elements in A that are not in set B. So we don't have one. Okay, we don't have 1 in set B, so I'll write 1. So we have 2 in set B, I'll not write it. We have 3 in set B, I'll not write it. We don't have 5 in set B, so I'll write it. So all the elements that are in set A but are not in set B are 1 and 5. That implies that A difference B is 1, 5. So let's go to the next one. B difference A. It means all the elements that are in set B but are not in set A. So that means B difference A will be equals to, now let's go to elements in B that are, let's look for elements that are in B but not in A. So we have 4 here. 4 is not in set A and 6 is not in set A. So that implies that elements that are in set B but not in set A are 4 and 6. Then the last one here is A difference B difference C, means all the elements that are in A but not in B and C. So that is the meaning. So let's scroll down a little bit. Okay, so here we have set A difference B difference C to be equals to, now let's look for elements that are in A but not in B and C. So 1 is in A but not in B and C. I'll write it 1. Okay, I have 1 here. So which other one? 5 is not in B and C, so I'll write 5 as well. Okay, so this is the meaning of difference of 2 or more sets. So let's look into another one, which is subset. Set A is said to be a subset of set B if all the elements in set A are in set B, and it is denoted by this sign here. Okay, so look at the given example here. Set A equals to 2 1 3 and set B equals to what? 1 2 3. You can see that all the elements in set A are also in set B, so we say set A is a subset of set B. Let's look into another one, which is proper subset. Set A is said to be a proper subset of set B if all the elements in set A are in set B. That is one condition. Then the second condition is that, and there is at least one element in set B which is not in set A. So when that occurs, then it is referred to as a proper subset, and it is denoted by this sign here. So let's look into the given example. For you to have a proper subset, 2 conditions must be met. The first condition is that all the elements in set A must be in set B. We must see that. So let's look at it. 2 is here, 2 is here, 1 is here, 1 is here, 3 is here, 3 is here. So the first condition is met. That is, all the elements in set A are in set B. Then the second condition is that there must be at least one element in set B which is not in set A. Obviously, we have 4 and 6 which are in B but not in set A. So that means the 2 conditions are met. Then we can say set A is a proper subset of set B. That is the meaning. Okay, so unlike the previous one here, look at what we have here. The members in the 2 given sets must be equal. Okay, they must be equal. So that is when you have a subset. But for proper subsets, they must not be equal. All the elements in set A must be in set B, and there must be at least one element in set B which is not in set A. So let's look into another one, which is called superset. Superset is the continuation of our subset. Okay, so let's say we have set A. Okay, set A is said to be a subset of set B if all the elements in A are in B. So I explained this earlier. So if this condition is met, okay, then we can say that set B is a superset of A. On the previous page, we said A is a subset of set B. So for the superset now, if we want to start with B, okay, then we will say B is a superset of A. Okay, that is just the implication. So it's the same condition you have for your subset that you have for your superset here. Okay, well, it's just like you saying x is less than 2. Okay, so this is one way. Another way of saying it, if you want to start with 2, is that 2 is greater than x. So that is what we are saying here. So if you say A is a subset of B, then B is a superset of A. Okay, let's look into another one. That will be proper superset now. Okay, so just like the way we said that A is a proper subset of B, then in the same way we can say B is a proper superset of set A. Okay, so you know, for you to have a proper subset, so the two conditions must be met. Okay, that is, all the elements in set A must be in set B, and there must be at least one element in set B which is not in set A. So let's check this. 2 is here, 2 is here, 1 is here, 1 is here, 3 is here, 3 is here. Okay, the first condition is met. Okay, now the second condition is that there should be at least one element here in set B which is not in set A. So the second condition is also met. So that means we can say set A is a proper subset of set B. That means set B is a proper superset of set A. As simple as that. Okay, and the last one we are going to look into here will be power set. Okay, so the power set is just the number of subsets you could have in a given set, the number of subsets you could form from a given set. Okay, so let's say you have set A to be equals to, let's say, 2, 3 and 4. Okay, so the power set now will be the subset you could form from this, and in this case it will be it will be 2. You can form one set, you could form another one, 3 here, so you could form another one here, that is 4. Okay, so you could form another one which should be a combination of two elements. You can have 2, 3. Okay, that's another one. You could have 2, 4. That is another one, and then you could have 3, 4. Okay, we are almost done. It remains 2. Okay, that will be the combination of the 3. That will be 2, 3 and 4, and the last one is an empty set. Okay, so the power set that could be formed, the power set of set A will be this, and this. Okay, that is a total of 8. So how do we know the number of subsets we could form from a given set? Okay, which is referred to as the power set of the given set. Okay, is by using the formula, the power set P equals to 2 to the power of n. Okay, where n is the number of elements in the given set. So in this case we have 1, 2, 3. We have 3 elements in set A, so that means the power set will be 2 to the power of 3, which is 8. That means you can form 8 subsets from set A, which are listed here. So that is how you can get the number of subsets you could form from a given set. So this will be the end of this video. Okay, in the next video I will discuss Venn diagram, that is introduction to Venn diagram. Thank you.